Good day, fellow Ateneans. This is Joan Sahali, a member of the ADZU SHS Mathematics Club, and I will be answering here few problems on the lessons 1 to 3 of STM 1 to 5 or General Physics 1, which may help or guide you on this coming exam week. So first, we have here the lesson 1 guided practice about measurements, where we are asked to look for some objects that you collect at home. These objects may include posters, pictures, bills from different places, books, cards, and etc. Measure the object's length and width using a ruler or a tape measure and record the data, then convert it into a different unit. So here they gave us an example of a birthday card with a length of 4 inches and a width of 6 inches. Here they show us on how they converted it into foot and yard. Now let's say we have an example of a floor mat with a length of 36 inches and a width of 27 inches. Now, we will convert the length into foot. We will change this to foot instead of kilometers since it will be too big for our example. And we'll convert the width into yard instead of miles since again it will be too big for our example. Now, let's proceed to solving. Now, according to the table of conversion of units, 1 foot is equivalent to 12 inches, while 1 yard is equivalent to 3 feet. Now, what we're gonna do first is we're gonna convert the 36 inches length into feet. And then we are gonna use this equation, 1 foot is equivalent to 12 inches. So the first step to do is to write this 36 inches into fraction form and multiply it into another fraction. And notice that we have the unit inches on the top, so we're gonna put this 12 inches on the bottom and 1 foot on the top, so that we could cancel the unit inches. And we're just going to simplify it, 36 divided by 12, which is 3 feet. And that's it, we're pretty much done with the length. Now we're gonna proceed to the width, convert 27 inches into yard. So we cannot directly convert inches into yard, so instead we're gonna convert 27 inches first into foot, and then foot into yard. Again, we're just gonna write this 27 inches in fraction form. Again, notice that we have the inches on the top, so we're gonna put again this 12 inches on the bottom and 1 foot on the top, so that we could cancel the unit inches. Again, we're going to convert this foot into yard. Notice that we have the foot on the top, so we're gonna put this 3 feet on the bottom and 1 yard on the top, so that we could cancel this. And we're left with the unit yard. And then last step is to simplify the equation. 27 divided by 12 equals 2.25 divided by 3. We have 0.75 yard. And that's it. We've converted 36 inches into foot and we got 3 feet. And then 27 inches into yard and we got 0.75 yard. Now, next example, we have here photo album with a length of 20 centimeters and a width of 28 centimeters. And we are asked to convert the length into inches and the width into meters. So according to the table of conversion of units, 1 centimeter is equivalent to 0.39370 inches and 1 meter is equivalent to 100 centimeters. Now, first is convert 20 centimeters into inches. Again, we're gonna write 20 cm into fraction form, 20 cm over 1, and multiply it into another fraction. Notice that we have centimeters on the top, so we're gonna put 1 cm on the bottom and 0.39370 on the top, so that we could get rid of the centimeters unit. And then we're just going to simplify the equation. 20 times 0.39370 is equals to 7.874 inches. And that's it, we're done with the length. Now moving on to the width, convert 28 cm to meters. Again, we're gonna write 28 centimeters into fraction form, multiply it into another fraction. We're gonna put 100 cm on the bottom and 1 meter on the top, so that we could get rid of the centimeters unit. And then again, just simplify 28 divided by 100. We will get 0.28 meters. And that's pretty much it. We've converted 20 cm to inches and we got 7.874 inches. And then 28 centimeters to meters and we got 0.28 meters. Now, for the sake of practice, we're gonna have another example. This time, speed naman. Let's say we have 32 km per hour and we're gonna convert that to meters per second. Now, we all know that 1 kilometer is equivalent to 1,000 meters. 1 hour is 60 minutes. And 1 minute is equivalent to 60 seconds. Now, first thing to do is to write 32 km per hour into fraction form, like this. And then multiply it into another fraction. We're gonna put 1 km below. And then 1,000 meters on the top, so that we could get rid of the km unit. And then we're gonna convert r into minutes first, then to second. We're gonna put 1 hour here on the top so that we could get rid of the unit r since it's on the bottom. So we're gonna put this on the top. And then 60 minutes. Cancel. And then again, we're gonna convert minutes to seconds. 1 minute on the top and 60 seconds on the bottom so that we could get rid of this unit. And that's it. We're just going to simplify the whole equation. We're gonna multiply 32 by 1,000 and then divide it by 60 and then divide it again by 60. Please grab your calculator and just key in the equation into your calculator. 32 times 1,000 divided by 60, again divided by 60, and we will end up with 8.88 meters per second since yun na lang ang natitirang unit, this one and this one. And that's pretty much it. We're done with lesson 1 and we're about to move on to the lesson 2, which is vectors. And now we're on the second lesson, which is vectors, and on the page 56 of your module, you can find the guided practice of the lesson 2. So directions. Choose at least 2 rides, then solve for the components of the vectors. Write your answers on the boxes found on the next page and show complete solution. So when solving for the components of the vectors, we have here 2 sets of formulas. We have this one and this one. We will only use this one if and only if our angle theta is between the vector and the x-axis. But once our angle theta is between the vector and the y-axis, we're gonna use this formula, not this one. But since it's stated here that the theme park lies on quadrant 1, then obviously we're only gonna use this set of formula because all angle theta will be between the vector and the x-axis. So here we have roller coaster, Ferris wheel, merry-go-round, and haunted house. And on the direction, we are asked to choose at least 2 rides. So let's say I chose Ferris wheel with a magnitude of 65.9 meters. Wait. Ferris wheel. Magnitude A, 65.9 meters. And angle, 45 degrees northeast. Now, to solve for the components of the vector, we will use this formula for the x component and this one for the y component. Let us solve first for the x component. Ax is equals to a cosine theta, or 65.9 meters cosine 45 degrees. Now, just simply key in this equation to your calculator. 65.9 cosine 45 degrees. And that will provide us 46.59 meters. Oh wait, 46.6 meters. And then for the y component, we will use this formula. AY is equals to A sine theta. A sine theta. A is 65.9 meters. Sine theta, which is 45 degrees. And again, just key in this equation to your calculator. And we will have 65.9 sine 45. We will have again 46.6 meters. And that's it. Our x component is 46.6 meters as well as our y component 46.6 meters. Now next, another one. Let's say I chose the roller coaster with a magnitude of 88.9 meters and a direction of 70 degrees north of east. Roller coaster. A is 88.9 meters. Theta is 70 degrees north of east. Now again, to solve for the x and y components of the vector, we will use this formula again since our angle is between the vector and the x-axis. Ax is equals to A cosine theta. A is 88.9 meters cosine 70 degrees. Key in this equation to your calculator. We will have 88.9 cosine 70 degrees. We will have 30.4 meters. And then for the y components, again, this formula, AY is equals to A sine theta. A sine theta. A is 88.9 meters sine 70 degrees. Key in this equation to your calculator. 88.9 sine 70 degrees. And we will get 83.5 meters. And that's it. We have our x component 30.4 meters and y component 83.5 meters. That's pretty much it, but for the sake of practice, we will take another ride. Let's say we will have the haunted house with a magnitude of 165.6 meters and direction of 25 degrees north of east. We'll just write that down again. Haunted house. A is 165.6 meters. Theta is 25 degree north of east. Formula for the x component, Ax equals A cosine theta. A is 165.6 meters. 165.6 meters. Cosine 25 degrees. Key in this equation to your calculator, we will have 165.6 cosine 25. We will have 150 meters. For the y components, we will use this formula A sine theta. A is 165.6 meters sine 25 degrees. Again, key in this equation to your calculator. We will have sine 25. We will have 69.98. We will have 69.98 meters. And that's how you solve for the components of the vector. Just keep these formulas in mind. We will use this set of formula if and only if your angle is between the vector and the x-axis. And then this formula naman if your theta is between the vector and the y-axis. And now we're down to the third and last lesson for the midterm of General Physics 1, which is kinematics. And now we're on the third or last lesson for this video, which is kinematics. And here I've prepared 3 problems where we will be solving for the acceleration using the formulas that was introduced to us by our physics moderators. So number 1, determine the acceleration in meter per second squared of an object which A, moves in a constant speed of 20 meter per second in a straight line for 12 seconds. So basically, our acceleration is 0 because it is said here that an object moved in a constant speed and in a straight line. Acceleration is actually the measure of how fast or slow the velocity changes. And in this situation, the velocity did not change, either the direction also did not change. So yeah, that's pretty much it. Our acceleration is 0. Now for the second situation letter B, determine the acceleration in meter per second square of an object which changes its velocity from 12.1 meter per second to 23.5 meter per second in 7.81 seconds. Now let's identify first what was given. We have here an initial velocity of 12.1 meter per second, final velocity of 23.5 meter per second, and given time 7.81 seconds. And what is missing is of course the acceleration, and we will use here the basic formula for an acceleration, which is the change in velocity over the change in time. Change in velocity is Vf minus Vi, and for the time, we only have one given time here. The time did not change, so we will just put here simply time. And we will just substitute our given to the formula. Vf 23.5 meter per second, Vi 12.1 meter per second, and time 7.81 second. Now key in this whole equation to your calculator and you will have your acceleration. On my end, it's 23.5 minus 12.1 all over 7.81. I got 1.46 when rounded off to the nearest hundredths place. Yeah, meter per second square. And that's our acceleration for the situation letter B. Now moving on to the last situation, it says here, determine the acceleration in meter per second square of an object which accelerates from 33.4 meter per second to 18.9 meter per second over a distance of 109 meters. Again, first step, we should identify first what was given. So we have here an initial velocity of 33.4 meter per second. This is initial 33.4 meter per second. And then final velocity 18.9 meter per second, distance 109 meters. Missing acceleration. In this situation, we will use the formula A is equals to Vf squared minus Vi squared all over 2D. This is converted from the fourth equation on the 4 kinematic equations, which is this one. And yep, we will just substitute our given into the formula. Vf squared, we have 18.9 meter per second squared minus our initial velocity 33.4 meter per second squared all over 2 times our distance 109 meters. And then again, key in this whole equation to your calculator and you will have your acceleration. 18.9 square minus 33.4 square all over 2 times 109. You will have, here on my end, I got negative 3.48 rounded off to the nearest hundredths place meter per second square. And that's our acceleration for our last situation. Notice that we got a negative acceleration here. Worry not, that's normal because as you can see, our velocity changes from 33.4 to 18.9, meaning the object slowed down, so our acceleration decelerated. So it's normal to have a negative acceleration. And that's all for my video tutorial on the lessons 1 to 3 of STM 1 to 5 or General Physics 1. I hope you learn a thing or two from me, and I hope to see you soon on our next video tutorial. Thanks and good luck on your midterm exams. Bye!